Okay, guys, so let's go with the second and last part of this worksheet. This part is, I think, easy. We're not gonna take a long time here. So let's go to the chase and let's start right away. So let's talk about the median of a triangle. The median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So we're gonna say the median of a triangle is a segment, right? Whose endpoints are a vertex and the midpoint of the opposite side. I'm going to explain this with an example later so you can understand it better. Okay, and the altitude of a triangle is a perpendicular segment. So let's put it here, is a perpendicular. What does perpendicular means? Perpendicular means 90 degrees. Okay, so an altitude of a triangle is a perpendicular segment from a vertex of the triangle to the line containing the opposite side. So to the line that contains the opposite side. So I'm going to explain these two concepts of median and altitude using actual examples of triangles so you can understand better what I'm talking about. So let's talk about two theorems here as well. The first one is concurrency of medians theorem, and the second one is concurrency of altitudes theorem. Altitude means heights. Okay. So it says here the point of concurrency in this theorem is called the centroid. So remember, in the past video we learned about circumcenter, about incenter, and now we're gonna learn about something called the centroid. Okay. So the centroid, which is the point C, let me put it here. In this case, the centroid is this point over here, the point C, right? You can see here. The centroid point C splits the median into two smaller segments. But okay, let me put this here and then I explain to you what is two smaller segments. Okay, before I continue, I want to explain to you, since we're talking about medians, how does a median look like in a triangle? So let's read again. The median of a triangle is a segment. It means a line, right? A segment is a line whose endpoints are a vertex and the midpoint of the opposite side. So, for example, this line over here, the endpoints are the vertex and the midpoint of the opposite side. Remember, what is the opposite side to this angle that we have here? The opposite side is this one, the side J. And what is the midpoint of J? This one, right? So the endpoints of this line are the vertex of D, right? And the midpoint of the opposite line. Again, here, what can I say? For this line, one endpoint is the vertex and the other endpoint is the middle of, or the center of, the opposite side, which is the side H, right? And this one endpoint is E, right? And it goes to the center of the opposite side, which is G, right? So in this case, we have these three lines, right? So let me put these lines like this. I'm gonna put them like this for a moment, but later I'm gonna change the colors because you're gonna see what's going on, okay? So we have this line over here, this one, Hold on, what did I do? Okay. Remember, this line goes from the vertex to the middle point of the opposite side, right? Same as here. Hold on. We have this over here. And finally, we have this one. I don't know what the lines are not. Okay. Okay. So the point when these three lines cut each other is going to be, again, the centroid. And put it in green on top of them. This is the centroid. Okay. So, as you can see here, the centroid, which is the point C, right, splits the median into two smaller segments. Okay. So, what I'm saying this here is this line, you can understand it as two parts. This is the short part and this is the long part. So this is the long part and this is the short part. Again, here we have the long part and the short part, right? And here, this one, I have the long part and the short part, right? So as that's what I'm saying here. So whenever you have any of these medians, right? So you always have two smaller parts, the long and the short. Okay, so I'm gonna say that those two parts are half length of each other. So hold on. Half length of each other. What do I mean by that? Okay, for example, so if this line is, let me write it like this, and I'm gonna change the colors here because I want to be very specific here. I just use this color purple to show you how the centroid is found, right? Now I'm gonna change the colors for a moment so you can understand this a little better. Okay, I'm gonna stop using this purple over here, and I'm gonna use actual colors. So I'm gonna say, so whatever line you have here, you can divide it in two parts. Let's say this blue part, right? And this red part, right? So what I'm saying here, okay, those two smaller segments, which is this one and this one, right? They are half length of each other. It means, like, for example, if I decide to call this one 2x, what is the half of 2x? Well, it's just x, right? And that happens with all of them. For example, this one, and this one, right? So if this one is 2x, this one is what? X. And again, with the other one, if this one, let me fix it, okay. Okay. If this one is 2x, okay, what is this one? This one is gonna be x, right? Let me fix it a little here. Okay, so what I'm saying with this is we're using blue for the small lengths, right? And we're using red for the large lengths. So what we can say is, okay, the small plus the large is equal to the whole thing, right? So who is the small? So the small, remember, we said, okay, The small ones are x. So we're gonna say here, okay, the small is x. And the large, what is the large? The large are 2x. So, okay, x plus 2x is equal to what? 3x, right? So if you know that, that's more than enough. We don't need to do anything else here, because since if you know this proportion, you're gonna be able to solve everything, okay? So now that you understood this one, I want to, using this, I'm gonna solve these exercises, okay? Well, some of them, and the other ones are gonna be homework, okay? And then when I'm done with that, I'm gonna explain this one, and you're gonna solve, well, I'm gonna solve some of these ones, and you're gonna solve the other one, okay? So let's read. Example 3. Use the given figure, triangle X, Y, Z, it means this one, right? Where A is the centroid. So if we're learning about centroid, we're gonna use this thing that I just explained to you how to use, right? And find what is being asked, okay? So same as in the previous exercise, we're gonna use this information for this triangle, and when we're done with this exercise, we're gonna erase whatever information we put here, and we're gonna put the new information in the same triangle, blah, 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 okay? So let's solve this. In this case, they are telling you that A, which is this point over here, right? This point over here is the centroid. So we're gonna find what is being asked. So guys, let me show you something. If we have this line over here, what do you think is the small and what is the large? So of course everybody will be agreed that this one over here is the large, right? And this one over here is the small, right? So let me put them with colors. This one is the small, right? Let me put it like this. This is X, right? And this one is the large, which is this one, right? Okay, we're gonna call this one 2x. Same with the other ones. So this one, come on. I don't know why this app is doing this. Okay. So this one is the short one or the small one, right? And this one is the large one. Let me fix it here. This one is 2x, right? And the last one is exactly the same thing. So let's go ahead and do this one. This is the large one. So this is 2x, and this is x, right? Guys, technically, these lines that I just put here, the blue ones and the red ones, are the same for all of the 3 exercises, okay? What is going to change is the information that is being given in all of them, in each one of them, I mean. Okay, so in this case, they are telling you, if dz, which is this one, so dz is this distance over here, right, is equal to 12, then find AD. Who is AD? Only this part over here, from D to A. So technically, they're telling you all of this is 12. So what is this little part over here, right? So let's do it. So if dz is 12, which is this one, right? dz is 12. So I'm going to put it here. dz, which is equal to what? dz is the whole distance from here and here. How much is x plus 2x? 3x, right? dz is 3x. And they're telling you dz is what? 12. So this is equal to 12, right? So what is dA or AD, which is the same, right? This one. What is this distance? this distance is x. So if we can find x from this equation, we're going to be able to solve the exercise, right? So I'm going to say, okay, so as I know that you don't like solving using manual methods, let's solve it using Desmos. But anyway, you should be able to solve this one manually. But anyway, it's fine. So let me just put it here. Why is it not working here? Okay. So remember that the way to solve this in Desmos is I just make the left part equal to y, the right part equal to y, right? And then you just solve in Desmos, right? So in this case, I'm just gonna put here, okay, y equals 3x and y equals 12. And then I find the intersection, right? I'm gonna take a screenshot of this and I'm gonna put it there for you so you know where I got the answer from. Okay, go ahead and put it here. Okay, and since we're looking for x in this case, which is what? 4, right? So I can say from here, I can say x is equal to 4. Okay, so remember, guys, one more thing, because I know you. You're gonna tell me, why didn't you put this part in the equation? Why only you only put this part? Of course, this is just explaining that the segment DZ is equal to 3x, but at the same time I know that 3x is 12 according to the exercise, right? So you don't have to put this when solving the equation. This is just additional information that they're giving you in order to identify how to create the equation, okay? So now that you know that x is 4 from this formula, right? Okay, so the question now is, who is AD? So AD, I'm gonna put it here. Hold on. AD segment, right, is equal to what? Or, well, AD or DA is the same thing. Is what? X. AD or DA, which is this one. According to this, what is it? X. So AD is equal to x. But who's x? We just found it. X is equal to 4, right? We just found it here. So therefore, I can say, okay. Okay. So now that you know that, you're gonna solve this one and this one on yourselves. For example, I'm gonna help you telling you a hint for the letter B. So if AB is equal to 6, okay, they're telling you AB, which is this little part over here, is 6. Then who is BY? BY is going to be the whole thing over here. If you know that this is 6 and this is the double, 2 times 6, okay, what do you have to do? Add these two quantities, 2 times 6, you know what you have to do. So try to solve it by yourselves, okay? Oh, remember, I forgot we say this is homework, not classwork, okay? So let me just copy this here, and this one, you're gonna solve it the same way. And finally, let's talk about the second theorem, or the fourth theorem actually, because I told you 4 theorems today. 1, 2, 3, and this is the fourth one, right? So concurrency of altitudes. So now let's talk about what an altitude is. So an altitude, guys, is a perpendicular segment from a vertex of a triangle to the line containing the opposite side, okay? So I'm gonna use this one first to show you how the altitude works, okay? And then I'm gonna apply the same idea to find the altitude of this one and the altitude of this one, right? So how does it work? For example, what kind of triangle is this one? This triangle is an acute triangle, right? How do I identify an acute triangle? Because all of the angles are less than 90 degrees. So this angle over here, this angle over here, and this angle over here, all of them are smaller than 90 degrees. Okay, less than 90 degrees. Okay, let's focus on this triangle. Again, let's read this. The altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. So this is one vertex and it's a perpendicular line to the opposite side. What does perpendicular mean? That forms a 90 degrees angle, right? So in this case, I'm gonna say, okay, so it's a line that comes from the vertex and goes to the other side, forming a what? A 90 degrees angle. Let me put the 90 degrees angle here, in maybe in blue. Oh no, let's use orange for this one. Okay, there's the 90 degrees. Okay, let's do it with the other one. So the other vertex is this one, right? So this is gonna be a line that goes from that vertex, right, to the opposite side, right, forming a 90 degrees angle. Again, here's the 90 degrees angle. Got it? And finally, this one. This comes from the vertex B and goes to the other side, right, forming what angle? 90 degrees. Remember, 90 degrees, 90 degrees, and 90 degrees, right? Okay, now let's talk about the next type of triangle. The next type of triangle, what kind of triangle is this one? Yes, it's a right triangle because we have a right angle in one of the vertex, right? So we're gonna call this one a right triangle. So I'm gonna show you what's gonna happen with this one. So in this case, we have this vertex. But let me show you. If I draw a line like this one to the other side, is this a 90 degrees angle? No. What if I do this? Is it a 90 degrees angle? No. If I do this, is a 90 degrees angle? No. So technically, the other side is this one, right? And the 90 degrees is here. So in this case, this one would look like this. So it comes from this vertex, which is A, right? And extends to the other side, forming what? A 90 degrees angle, right? Okay. Now, let's talk about the vertex B. So the vertex B is this one. Look at this one. If I do this, sorry. If I do this, is this a 90 degree? No. If I do this, is a 90 degree? No. If I do this, is a 90 degree? No. The only way is to do it like this. Pay attention. This one goes here and intersects this one, which is the opposite side, forming a 90 degrees angle, right? So technically, this one would be something like this. Okay? And the 90 degrees is still here, or here, which is the same, right? Okay. And finally, the other one would be something like this. Where is the vertex? C. And we're gonna go to the opposite side. This one is super easy because this one forms a 90 degree already, right? So it's gonna be something like this. And the 90 degrees is here. Okay. Guys, these lines that I'm writing here, these arrows in purple, guys, you can extend them if you want. You can project them, okay? So I'm gonna project these two in order for you to let you see the exercise a little more illustrative. Okay, let me just extend these lines. I'm just gonna pretend that this one is extend. Oh, hold on, it's extended over here. Extend it like this. Okay, I'm gonna extend this one like this, right? And as I told you, you can extend it if you want. It doesn't matter. What I mean when I say extending is like you can do this, right? And you can do this. It doesn't matter. Like you can extend a line if you need it in order to understand better. Okay, so guys, if I ask you, okay, what is the point where these three lines cut each other? Okay, this one goes like this one goes like this, and this one goes like this, right? When do they cut each other? Here, in this part. So for a right triangle, the orthocenter is gonna be in the middle. Okay, in the middle, in the sorry, in the 90 degrees angle of the triangle, which is this one, right? Let me just put it here to let you see better. Okay, and in the other one, same thing. Where is the point where all of them cut each other? In this part, right? Okay, now in the last one, what is the last type of triangle? This type of triangle is called an obtuse triangle, right? So let me just write here it to identify each triangle. Okay, the first triangle, which is acute, the characteristic is that all of the angles are less than 90. When it's a right triangle, it's because we have one angle being equal to 90 degrees, right? And in the obtuse, we can say that there's one angle which is greater than 90 degrees. Okay, so I'm gonna say here one angle is greater than 90 degrees. Okay, so we're gonna use we're gonna use the same logic we have been using in this one and in this one to find where the 3 points where the three lines converge or cut each other, right? So the first one, let's imagine this vertex. The triangle is this one, right? So this vertex, the opposite side, everybody agrees, which is this one, right? So the angle, the projection would be something like this. But if I do this, is this a 90 degrees angle? No, we need it to be perpendicular. If I do this, is a 90 degrees angle? No. Is a 90 degrees angle? No. But what if I I know this side finishes here, but I can extend it if I need it, right? Remember I told you, you can use projection lines if you need them. So I'm just gonna extend this side like this, right? And let me use another kind of, let me use this one. Okay, let's extend this side like this one, right? And now I can say, okay, if this is the vertex, this is not 90, this is not 90, this is not 90, this is not 90, but this is 90. Do you see this right angle over here, right? So here and here I can form a 90 degrees angle, right? So in this case, I can say, okay, this is the vertex and this is coming from here and it's going towards the blue line, and I'm going to extend it even more, right? Because I need it. So this is a projection line. Actually, this line is not inside the triangle, right? This line is not inside the triangle. I'm going to just put it dashed in order to be a little more illustrative here. So I'm just going to put it dash here. Okay. So now let's do the same with the other. So with this point over here, the opposite side is this one, right? But if I do this, this is not 90, this is not 90, this is not 90, this is not 90. But if I continue to extend this line more over here, let me put it here in blue, so you can, oh, hold on, so you can see, right? So now I can say, okay, if this is the vertex and I extend this line, which is the opposite side, I can form a 90 degrees angle here, right? So in this case, I'm gonna say this is gonna be something like this, right? Okay, and finally, let's talk about, we talk about this vertex, this vertex. Now let's talk about this vertex, right? So in this case, this vertex, of course, this is super easy. It goes to the opposite side, forming a 90 degrees angle. I'm just gonna put it here. Let me show you. Okay, hold on. It's coming from here and it's going the other way, right? And it forms the 90-degree angle. Remember that all of this, the main idea, all of these ones is to form 90 degrees, right? 90 degrees, 90 degrees, 90 degrees. Right? So as you could say, okay, but okay, these two are cutting each other. What but about this one? This one is not cutting the other two, right? Well, as I told you, you can extend a line if you need it to, right? So in this case, what I'm gonna do is I'm just gonna extend this line. So instead of having it like this, I'm just gonna extend it over here, right? And it's gonna be something like this, right? So the point where these three lines cut each other is actually outside of the triangle, right? It's over here. So in this case, the orthocenter of this thing is gonna be over here. And you have been saying, okay, why are you mentioning the word orthocenter? Well, in this previous theorem, we called the point where in the middle, we called it centroid. But in this case, this point over here, we're gonna call it orthocenter. So that's why I'm gonna call this one the orthocenter. Okay. So it says the segment of altitude represents a vertical distance. Let's put it here. Okay, on a triangle. The vertical distance of on a triangle means the height. Okay, that's why they're saying you can call this vertical distance also a height. Depending on the type the type of triangle, we will find out that the point could be either here, or either here. Either if the triangle is acute, the orthocenter is going to be right in this, well, not right in the center, but inside the triangle. In the case of the right triangle, the orthocenter is going to be in the right angle vertex. Okay, in this part, it's not going to be here, and it's not going to be here. It's just in the same spot where the right angle is. And in the case of an obtuse triangle, the orthocenter is going to be outside of the triangle, because remember the triangle is this one, the orthocenter is actually outside of the triangle. But anyway, guys, I know this could be a little confusing. You don't need to like get very crazy about this. Don't think much about that. So if you know that in an acute triangle, the orthocenter is inside. In a right triangle, the orthocenter is in the vertex of the right angle, and in an obtuse, the orthocenter is outside of the triangle. That's going to be more than enough. So let's solve a couple exercises, and uh, that's it. So actually, I'm going to solve these two exercises for you. And actually, I'm not going to give you homework on this one. I'm just going to explain how easy it is. And this is once again to show you that in the test, exercises are easier than you think, okay? So you don't have to do a lot of things. Like actually, guys, as you can see, in this one, I gave you like a formula, but in this one, I didn't give you any formula because technically, well, for this kind of exercises, you don't really need it. So let's see. Find the coordinates of the orthocenter. So are they say as they're saying orthocenter, we're gonna use this. We're not gonna use this, right? So find the coordinates of the orthocenter given a triangle's vertices. So they're giving you the vertices of the triangle, and we're gonna put those points in the coordinate plane in order for us to graph and identify what we're gonna do. Okay, the first coordinate is 1, 7. So 1 in x, which is here, and 7 in y, which is here. So if I connect those 2 points, it's gonna be over here, right? 1 in x, 7 in y is here, right? So let me put just the point here. Okay, let me put it a little more. Okay, we're gonna say this is the point 1, 7. Okay, the next point is 1, 2. 1, 2 is 1 in x, 2 in y is this one, right? So I'm gonna say this is 1, 2. And the last one is 11, 2. So 11, 2 is actually, let me put this a little thinner because I was using, put it like this, better, yeah. 1, 7 and 1, looks like a 7. Hold on. 1, 2, right? And the last one is 11, 2. So 11, 2 would be here. 11 in x, right? 11, this is 10, this is 11, right? 11 in x and 2 in y. It's going to be this point over here, right? So I'm going to put it here. 11, 2 is going to be this one, right? So let's say this is 11, 2. What are we going to do? We're going to join the points, connect the points, right? This one with this one, this one with this one, and this one with this one. Okay. What does this exercise say? Find the orthocenter. What are you going to do? What kind of triangle is this one, according to what you see? Of course, this is a right triangle, right? You see the right angle here. Yes or no? So you know that this angle over here is 90 degrees. This is a right triangle, according to what we learned. Okay, Mr. Gomez just told me. Okay, whenever I have a right triangle, the orthocenter is going to be always in the right angle vertex, right? So the orthocenter actually is going to be here. It's not a big deal, right? It's this one. And that's it. Okay, and they're telling you, give me the coordinates of that orthocenter. Okay, so what are the coordinates of this orthocenter? Actually, I have them here. It's 1, 2, right? So I'm just going to put this in green, and I'm going to say, okay, the coordinates of this orthocenter is 1, 2. Super easy. I didn't apply any formula. I didn't have to calculate anything, right? And let's solve the other one. Triangle's vertices. So they're giving you these 3 vertices. Let's put them in the graph and then connect them, and let's try to find the answer. So the first coordinate is 6, 10. So 6, 10, according to me, is here, right? So I'm going to put it here. 6, 10. Is that correct? Yes. Okay. The other one is 2, 2, which is here, right? This is 2, 2. And the last one is 10, 2. 10, 2 is going to be over here. I'm going to put it here. 10, 2. Let's join the points. Let's connect them for a moment. We have this one, and this one, right? Let me fix this a little. Okay. Okay. So we need to find the orthocenter of this thing. What kind of triangle is this one? What kind of triangle do you think is this one? Is an acute triangle, is an obtuse triangle, or is a right triangle? Is a right triangle? Of course not, because I don't have any angle equal to 90 degrees. Do I have any, is this an obtuse triangle? No, because in all of the triangle of the angles are less than 90. So if all of the angles are less than 90, we're talking about an acute triangle, right? And in an acute triangle, I told you, okay, the orthocenter is inside the triangle. And remember, the lines that you are projecting here go from the vertex to the other side so you can form a 90 degrees angle. So we're gonna do it by eye. It doesn't have to be perfect. So I'm gonna use just my eye to do a little sketch of what's going on, okay? So I'm gonna say, maybe I can form a 90-degree angle if I do something like this, yes or no? So I can do this and I can say, okay, I am forming a 90-degree angle here. Okay, there it is. This is 90 degree. So I did this vertex already, right? This one. Now let's go with this one. So I'm gonna do it by eye and I'm gonna, okay, go from here and I'm gonna go to the other side. So I'm just gonna go something like this. Oh, hold on, let me do it like this. Okay, and I can form maybe, is this a 90 degree? No. This a 90 degree? No. Maybe over here. I can say, yeah, here I have a 90-degree angle, right? So I'm just gonna put it here. Here I have a 90-degree angle. Let me fix it a little. Okay, here's my 90-degree angle. Okay, and let's go with this one. So this one, if I do a projection line from here and I go to the other, okay, the 90 degree is angle, is here already. Yes or no? So I'm gonna put it just here. Okay, let me put a little better. Okay, this is the 90-degree angle. Okay, and where are the three lines cutting each other? In this part, right? So I can say the orthocenter is here. Can you give me the coordinates of this point? Of course, this point is in the coordinates of 6 in x and 4 in y. So the coordinates of this is 6 comma 4. So simple, and I just put it here, 6 comma 4. And that's the answer, guys. So this is the way to solve these exercises. They're super simple. In the test, you're not required to do like a lot of things. So I just hope you understood this lesson. I decided to record this lesson, guys, because I probably know that you're gonna have trouble understanding this. So I decided to record it so you can like watch and rewatch the video as many times as you want, so you can understand it all the way. But anyway, if you have questions, please don't hesitate to ask in class or send me an email, and I will be happy to give you additional information, or we can, do arrangements for a tutoring or whatever. So I wish you all the best, and this is all about this lesson. Have a great night, well, or a great day.